All right, I'm going to make one more video here on solving some trigonometric equations, but this time we're going to do it by factoring. So let's see what's up. This looks factorable. I'm going to make a couple sets of parentheses, get my factoring going. First, I'll look at the first term, sine x squared. That can be factored as sine x times sine x. All right, sine x times sine x, that's sine x squared. Next, I skip over the middle. That comes at the end. Now I look at the 2. Ignore the sign for a moment. 2 can only factor one way. 2 times 1. That's it. Now here's the key to factoring, at least the way I do it. Inner plus outer equals middle. I'm going to say it one more time. Say it with me. Inner plus outer equals middle. Inner is this, 2 sine x. Outer is this, multiply those together. That is 1 sine x, or simply sine x. Now the middle to which I refer is this, negative 3 sine x. That's our target. So I can make negative 3 sine x out of these like terms only if both of these are negative. That's what tells me that both of these need to be negative. And take a look at that positive 2 one more time. Negative 2 times negative 1 is positive 2, so there you go. We have factored. Now when you're solving an equation by factoring, you take your factors and you set them each equal to 0. It's called the zero product property. Okay, that will give us one solution, and this will give us another solution. So solving this, of course, I'm just going to add 2 to both sides. So sine x equals 2. And similarly, adding 1 to both sides, sine x equals 1. Now, time to get our solution. Sine of what angle will give us an answer of 2? Well, unfortunately for that equation, this is nonsense, because we know from our work on a unit circle that every point on the unit circle has the form cosine comma sine. So basically every y value on the unit circle is the sine of the angle. And this is a unit circle, so the highest it goes is 1. All right, 1 unit. That's why they call it the unit circle. The lowest it goes is negative 2. All right, so y equals 1. That's the highest sine value. Y equals negative 1. That's the lowest. So there's no way we're going to get up to 2. So this has no solution. On the other hand, I guess I've already answered the second question. Where is the sine equal to 1? Well, up top here is where the y value equals 1, and that is the sine. So what angle is this? Well, this is pi over 2. So there you go. X equals pi over 2. All right, that'll be the only solution to this problem. All right, let's keep going. Okay, for a factoring problem, we really need to get 0 on one side. So I am going to add 2 cotangent x to both sides. And I'm going to add 1 to both sides. All right, none of these are like terms, so I'm just going to wind up putting them all next to each other. So I have cotangent squared x, just brought that down, plus 2 cotangent x, I'm just writing it side by side, and then plus 1, I'm just writing that all side by side. So just I'm moving both of these over to the left and getting 0 on one side. Now it's time to factor. cotangent squared can be factored as cotangent times cotangent. Alright, now I skip over to the end. 1 can only factor as 1 times 1. Inner plus outer must equal the middle. So inner, I have 1 cotangent x, and outer, I have 1 cotangent x. I'm trying to equal the middle, which is 2 cotangent x. I can make that happen if I allow both of these to remain positive. Positive 1 and positive 1 make positive 2, which means that both of these will be positive. And check one more thing. Positive 1 times positive 1 gives you positive 1 for the third term, so we're good. So now we have successfully factored. So of course now we set each of these equal to 0, so cotangent x plus 1 equals 0. Normally I would set the other factor also equal to 0, but it's identical to this, so there's no point in doing that. So subtracting 1 from both sides, that'll give us cotangent x is equal to -1. And it's time to analyze and figure out cotangent of what angle is going to equal -1. Now, the thing about cotangent is cotangent is the reciprocal of tangent. Okay, so 1 over cotangent is equal to tangent. Okay, these are reciprocals of each other. So if I take the reciprocal of both sides of the equation, which I'm allowed to do, the reciprocal of cotangent is going to be tangent. Okay, and the reciprocal of -1 is still -1. So this is the equation I'm more comfortable with, because this is where I have memorized things. So I'm going to deal with this version of the equation. So looking at my unit circle for a second. Well, first of all, here are some things that I have memorized. Tangent, everything on this chart you need to memorize, including the fact that the tangent of pi over 4 is 1. So that lets you know that pi over 4 is the reference angle that we should be thinking about. Okay, so I'm going to draw some pi over 4s here real quick. Alright, those are pi over 2s so far. But when I split those in half, they become pi over 4s. Alright, that diagonal is always the hardest to draw on my electronic tablet here. Alright, so these are pi over 4s. Alright, see how there's 4 of them? Anyway, so these are the 4 angles that have a reference angle of pi over 4. It's always the angles that are directly above and below the horizontal. So the thing about reference angles of pi over 4, if tangent of pi over 4 is equal to 1. Now, any angle that has a reference angle of pi over 4 is going to give me some kind of a 1 for an answer. Except for some of them, 2 of them will be positive and 2 of them will be -1. So another thing that's useful to memorize is where tangent is positive and where it's negative. Tangent is going to be positive in the first quadrant. Everything's positive in the first quadrant. Okay. And tangent is also positive in the third quadrant. Alright, that's worth memorizing. And tangent is negative in the second and fourth quadrant. So for this particular problem, we want the tangent to be negative. We want -1 specifically. So we want this angle and this angle will be the solutions. So what are these angles? Well, right here, this is 1 pi over 4, 2 pi over 4, 3 pi over 4. 4 pi over 4, 5 pi over 4, 6 pi over 4, 7 pi over 4. Alright, so those are the two solutions here. So x is equal to 3 pi over 4 or 7 pi over 4. Hop, that looks like negative 7 pi over 4, but it's not. And so that's it for number 22. Okay, for number 23, here's the common mistake, the one thing you cannot do. You cannot divide both sides by the trig function like this. And oh, I'm just going to cancel these out, and I'll just have sine squared x is equal to 1 or whatever. That's no good because you never know when cosine is going to equal 0. That is a value that cosine sometimes is. And so for all you know, you're dividing by 0 and you're breaking the fabric of the universe. You don't want to be responsible for that. So instead of dividing by something that could be 0, you want to subtract this term from both sides. It's basically get 0 on one side like we did in the previous problems. So we're going to have sine squared x cosine x minus cosine x is equal to 0. Now we can factor this because cosine x is a common factor. So I'm going to take that common factor and pull it outside of some parentheses. So that will leave sine squared x, all right, minus 1. Like that. Okay, and you could imagine doing the distributive property and you can see that you would get back to what you started with. So this is valid and good. Let's see. Now I could set both of these equal to 0 and use the square root property over here on the right. But this is a factoring problem. So maybe we'll try this one by factoring further. So remember the difference of two squares. If I had n squared minus 25, for example, if I were factoring this, I could do n plus 5 times n minus 5. All right, it's a little pattern that we memorized, difference of two squares. So if you have an equation that you need to solve, if I have n squared minus 25 equals 0, sure, I could add 25 to both sides, and then I could take the square root, and I'd get n is equal to plus or minus 5. But another option is I could factor it, and then I could set each of these equal to 0, and I'd get n is equal to negative 5, n is equal to positive 5, same thing. So you have a choice, and that's the same choice that we're dealing with right now. I'm not sure why my eraser is not working, but whatever. Okay, now my pen's not working. Okay, so I'm going to factor this by the difference of two squares. So I'm going to keep the cosine out front, and I will just factor this. So difference of two squares. So this will be sine x plus 1, sine x minus 1, difference of two squares. So I can get a solution by setting each of these three things equal to 0. Okay, so I can have cosine x equals 0. That'll give me a solution. I can have sine x plus 1 is equal to 0. And I can have sine x minus 1 is equal to 0. So I could have three different solutions here. So let's check it out. Cosine of what angle is equal to 0? Well, in the unit circle, cosine is the x value. So where is the x value equal to 0? Right in the middle. Alright, so the x value is equal to 0 here and here. So this is going to be pi over 2 up there. And this is 2 pi over 2, 3 pi over 2. down here. So I have two solutions to this right here. So far I have x is equal to pi over 2 and 3 pi over 2. Now, looking at this one, if I subtract 1 from both sides, then I have sine x equals -1. Okay, fine. So where is the sine function equal to -1? Well, remembering that the sine on the unit circle is a y value, the question is, where is the y value equal to -1? And the answer is down here. Up here, the y value is +1. Down here, the y value is -1. Well, that is 3 pi over 2 again, all right, which I already had. So there's not really a point in writing it again, but I'm just showing my work. In my final answer, I will only write it once. Okay, so that's what that would, so no new solutions from that. Now, if I add 1 to both sides, then I'm going to get sine x is equal to +1. So sine of what angle is +1? Just change colors real quick. Oh, I already mentioned it. The y values are +1 up here at the very top. So that is pi over 2. So that would give me x is equal to pi over 2, which again I already had. So really, these are my only two solutions. This is just repeating. Okay, I think we have time for one more problem on this video. We already have 0 on one side, so we can go ahead and factor. I see that we have a common factor of sine x. So let's go ahead and bring that out. So if I pull out sine x, then that's going to leave 1 minus 2 cosine x behind. Whoops. Must have hit my button by accident. Okay, so I can go ahead and set each of these factors equal to 0 right now. So sine x equals 0, work with that, and then I'll have 1 minus 2 cosine x is equal to 0. This needs a little solving, so let's subtract 1 from both sides. So now I have -2 cosine x is equal to -1. And now if I divide both sides by -2, I'm going to get cosine x is equal to +1/2. So these are the two functions that I have to work with. So sine of what angle is equal to 0? So looking at my unit circle, remembering that on the unit circle, sine is the y value. So the question becomes, where is the y value equal to 0? Well, the y value is equal to 0 right at the x-axis. Okay, so the y value will equal 0 here and here. So this is where the sine function will be 0, here and here. So this is 0 and pi. So that's what I have so far. 0 and pi. Let's see, maybe I'll switch colors so I can use the same circle again. So, cosine of what angle is equal to 1/2? Well, let's look back at the chart of things we are supposed to memorize. Everything on this chart you need to have memorized. So, here's cosine, here's 1/2. Cosine of pi over 3 is 1/2. That tells me what the reference angle is going to be, pi over 3. So I like to then draw a picture of pi over 3's. Alright, looking at the top half of the circle, that's pi. I've divided into the top half into 3 parts. So each one of these is 1/3 of a pi, or pi over 3. Now, these 4 angles are the angles that have a reference angle of pi over 3. So if I take the, and I know that because they're just directly above and below the horizontal. So the cosine of any of these four angles will give me some type of 1/2. It's just that two of them will be positive and two of them will be negative 1/2. Now remember that on the unit circle, every point x and y is a cosine and a sine. So in other words, cosine is the x value on the unit circle. So remember that the x value in the coordinate plane, look at the x-axis, the positive x's are on the right hand side and the negative x's are on the left. So that's why this will be positive cosine over here, and these angles over here on the left will give me a negative cosine. Now for this particular problem, we want cosine to equal positive 1/2. So that's why the solutions are going to be these two angles. Alright, and what are these angles? Remember, the reference angle is pi over 3 right here. So this is simply pi over 3. Okay, let me just jot that down. My little list. And what about this one right here? Well, this is 1 pi over 3, 2 pi over 3, 3 pi over 3, 4 pi over 3, 5 pi over 3. Okay, so you know what? Maybe can I bring these down and just make one complete list? Put it all together for a brother. So I've got 0 and pi over 3 and 5 pi over 3. So these are the four solutions to the equation. Alright, and we are at 22 minutes, so that's plenty long enough for this video. So I'm going to call it a day. I'm going to have one more video coming after this to complete this worksheet, so I will see you on that video.